Hi everyone, welcome. I hope you had a great week. We are back for Maps of Science. We're going to continue where we left. And as usual, I'm going to share with you the place where you can find useful resources for the topic of today. So I'm pasting the link in the chat now. I hope you can hear me well. I didn't do a sound check. I think everything is okay, but I could be wrong, so please let me know. We're gonna start in a few seconds. I'm just opening the Twitch stream to see if there's any viewer. Yes, there is one viewer. Welcome, dear individual. And we can start then. Okay, so the project consists in creating a map of science, which is a bit like, let me show you. Can you see that? Yes, a bit like that, and especially a bit like this here. So that's a map by Raffles, Porter, and Leidersdorf. And what they do is they computed similarities between journals of academic journals. And when you compute similarities between all journals and then you aggregate these journals per subject category, you realize that they connect in non-random ways. Not surprisingly, journals that are from the same scientific field tend to be connected compared to other journals, and so we're going to see what does it mean for two journals to be connected or similar. Before we get there, and where we left last week, we need a list of journals. We need a complete list of journals. So that's what we started doing using Java. Oh, I think I can increase the size of the, yes, you will see better here. Oh, great. So I use Java code to do something very simple, right? This is the URI, like the HTTP address of OpenAlex, which is a non-for-profit entity offering open data on journals, articles, authors, and organizations. So we call this API and we ask this API for journals. I have introduced a floor, which is I'm gonna include only the journals that have at least 50, that have published at least 50 articles. And so that's what we have done. But you can't have all journals in just one API call. You need to page, you need to retrieve the results page per page. So I've set the page size to 50, and then as you see, I have made some complicated. Okay, so that's the address here, but you see I have a loop. And then I have this fairly complicated thing where it makes concurrent, like parallel calls to the API. Super nice, but we had an issue, which is that it returned an error. If you make if you retrieve more than 10,000 journals, it stops with an error and it says you should use cursor paging. And we stopped there last week. And cursor paging doesn't work exactly like we did. So I'm going to just copy what we did and paste it below. So it should give me an error like this method or this function already exists. Yes, exactly. So paged with cursor. And we're going to follow the documentation of the API to do as they recommend. So I will not use concurrent or parallel calls to the API, and the reason is if you look at the documentation, where is the documentation? Oh, shoot. No worries, let me show it to you. Oh, it's there, I'm stupid. Okay, up. Okay, cursor paging. So that's documentation to do paging when you want to retrieve more than 10,000 entities. So it says, by the way, that the per page parameter can be any number between 1 and 200. So I'm going to put 199 first thing. Then what do they say? So that's basic paging here. Okay, super easy. You do a call, API that whatever, works, filter, whatever per page, and cursor equals star. So that should be your first call. So it's never gonna, or is it gonna stop? Yeah, okay, so the first, if this is the first call, so the first page, I should add cursor equals star. Oops. So no page. Oh, should I have a per page? I think so. Where is it? Per page, yeah. Fine. So this page thing doesn't exist. It's cursor. And basically, so this semaphore stuff, I'm just going to drop it because it was for parallel calls, but it's going to be not parallel. So if we are at the first page, then the cursor should be equal to star. Oh, maybe I should. Oh no, there is a better way to do it. Oh, you don't see my screen. You should tell me that. Okay, why? Okay, so the cursor has a starting value which is a star, but then it gets modified each time I receive a new response. So the HTTP request is there, and then I don't need a completable future. I just need a, where is it? Just like here. Just like here, should I say? Yeah, exactly here. I just received the response. Okay, so I received the response. I read the response. This is a JSON file. Okay, and the next cursor is fine. Don't need a scheduler. Look at that. Okay, all good. Fabulous. And I should just make sure that I wait a couple of milliseconds between two calls. What was the, there is a, I think it's time. There is an elegant way to stop the execution of a program in Java without using thread. I think it's called time. So of course it's thread sleep, which is the most, yeah, but that's exactly what I, time unit seconds. That's better, that's more elegant, I find. Time unit, seconds, sleep. So it's gonna be not seconds, it's gonna be milliseconds. And we're gonna sleep just 110 milliseconds, just to be above the limit set by OpenAlex. Okay, so we should be ready to make our first call. So I see there are 8 viewers. I can't even believe my eyes. 8 viewers. This is a crowd. So it's really worth me making my best effort to be clear. So dear viewers, dear crowd, what I was doing at the moment, maybe it was not super clear, is that I'm writing the code to retrieve the list of the 200,000 journals that exist and which are listed in OpenAlex. OpenAlex is this open database with the list of all journals and all their publications and all the authors of these publications. So how do I do that? You cannot retrieve 200,000 journals in one call. If you look at the code, you can retrieve batch, groups of journals up to 200 minus 1 journals per call. So that's why you have this page, per page. So I have retrieved just before the total number of journals. So to know how many pages I'm going to need, I just do a division. Then I round it to the, to the next number. And then that's what HTTP client, it's what this is how it's called in Java, the thing that connects my code, like here on my computer, to the internet. So you create this object that has the super capability to send requests to the internet. This horrible thing is just something that will, store the results I'm going to receive. And then this ugly thing here, cursor, is just the name of each page. When you receive a page, when OpenAlex sends you the 200 journals, it also sends you a unique code that you can use for your next request, for the next 200 journals. So the first request, you have no number, no ID. So they tell you in the documentation that for the first request, you should just use a star, an asterisk. Okay, and then it's super classic in code. You just loop, so you go for, you trigger the calls for as many pages as you need to retrieve. So that's what this thing does. And how does one call works? Well, you give it the address. So I'm looking for journals and stuff. This thing does no, it doesn't do the request, it just adds the request. It prepares the request if you want. And this single line is here. This one is the line where, is the line that does the call from my computer to their servers. And that's it. Then if it worked, 200 is the classic code for, okay, it worked, success. If it worked, then retrieve the body of the response, turn it into a JSON file data format, read it here, get the next cursor, get the ID of the next page you should ask, so that it's going to be used in the next call. And finally, read the results, all the journals, the 200 journals, and put them in the queue. And do that for all the pages. And when everything will be finished, and it might need a couple of, I don't know, I should do the calculus, by the way. When it's finished, just print all the names of the journals in a file. So I should have a rough idea, how long is it going to take. So I'm going to just do a quick computation using Google as a calculator. So 200,000 journals, but I have 200 journals per call. Oh, that's just 1,000 calls. And I do 10 calls per second. So it's going to take 100 seconds, which is less than 2 minutes, in theory. So now I'm going to launch it to see what happens in practice. I should open the window where we're going to see the results. Oh, it's here, but it's... Okay, you see output. That's where we're going to see things. and I should just trigger that. You know, I've created this function, but I've not, yeah, that's weird. So let's go, let's pray and run, my dear. So I'm just expanding the window for the output. So at the moment, nothing happens. It's just the program that 800 pages, even less than 1,000 that I had thought of. At the moment, nothing breaks. Well, I'm not going to wait 2 minutes, even if I'm going to be super curious. The thing runs. Let me have a second look at the code. So as you see, that's what I'm going to, when I get all the 200,000 journals, what it does is it's going to print its ID, then it adds this pipe character, you know, this vertical bar, and then it adds the name of the journal. And then it goes to the next line. And it prints that in a file called alljournals.txt. I'm so happy because it seems that it doesn't break. And we are close to 2 minutes. Yeah, I suppose it's going to be finished in the next seconds. I didn't use the timer, but yeah, I think we're nearly there. How long did I? Yeah. Okay, what's coming next? In any case, when we have this list, first we should celebrate and drink a bit of champagne, because that's just, and thank OpenAlex, because it's just amazing that you can access the list of so many journals in less than 2 minutes, or I hope in less than 2 minutes. So it's fantastic. And the second thing we should do after celebrating is work on the next step. So the next step is, if we want to have a map of journals, we want to have 2 journals connected if at least one person has written a paper in both journals, right? So to my knowledge, this has never been attempted, which makes things more exciting. But that's the idea. So how do you do that? And I'm still looking at the, come on, please work. Hopefully that's gonna work. Maybe I made a mistake in terms of, you know, in my very simple calculation. I mean, let me do the exact calculation. 800 pages. I do almost 10 calls per second, so yeah, it should be 80 seconds. And 80 seconds have passed. So I'm getting anxious. What happens? I think everything is fine, but we'll see. So what we need to do, what we need to do next is, for a given journal, we want to retrieve all the authors that have published in this journal in the past, I would say in the past 5 years. Yeah. 5 years is, well, 5 years is ambitious, because for some journals, they're going to have a lot of authors that that published in their, in their journals over 5 years. So I should cap or run or sample. But anyway, we'll say 5 years and see what happens. So for each journal, the list of authors that have published in this journal over the last 5 years. And the issue is, we need sorry, I just changed the sound, so if you can't hear me anymore, please let me know. I just diminish the sound. So how do we retrieve the list of authors for a given journal? I suggest we just go and check the documentation from OpenAlex. Authors get lists of authors. Yes, exactly. No, not exactly. Oh, yes. No, I don't know. How do I get that? Ooh, tricky. Filter authors. No. Well, I don't know how to do it efficiently, but I know how to do it inefficiently. If I don't find a better way, this is what I could do. I could loop through all authors, and there are millions of them. So this is bad, right? But I could loop through all authors and retrieve their publications. Oh, that's really a lot. And retrieve, not their publications, but retrieve the name of the journals where they published in the last 5 years. And in this case, I get what I want. But it means looping through through all authors, which is, I should really get in touch with OpenAlex, because that's a use case where you are not supposed to use the API for that. You are supposed to download a full copy of the dataset in a, on the cloud, and then you work on it. You're not supposed to ping their servers to collect all this information. The only thing is that I don't have the data engineering resources to set up, and I don't have the money either to set up a cloud instance where I would host the 100 of gigabytes, or I can't remember how large that is. So my hope is that if I ping all authors, but I'm super gentle, you know, I'm not asking for a lot of information, I'm just asking for the list of the journals where they published. So I'm not asking for their names, I'm just taking the ID of the author and the ID of the journals where they published. And even less, actually. I just take the ID of the authors that have an ORCID ID. You know, sorry, I'm going to just switch on the light. I'm going to just take the authors that have an ORCID ID, because otherwise I can't disambiguate authors. And authors with an ORCID ID, there are not many of them actually. So I'm still getting in touch with OpenAlex to at least to tell them, you know, that's how I'm going to use the API. Please be nice. Okay, so is there a better way? If I could get the list of authors from a journal, that would be, I suppose that would be more efficient. I didn't do the count, but so the source, a source is a journal, right? Yeah. So can I get the list of authors from a source? I suppose not, but let's check that. No, of course not. It would make no sense from a data modeling perspective to have authors. Group sources, what's that? I was supposed to open the light and nothing happened. Let me, yeah, because the switch is a bit weird. Okay, we have light. Group sources, what does it mean? Oh, by attribute, so it's not what we need. Okay, I'm super sorry, but it seems like I'm gonna have to loop through authors. What is work? Paging through all the authors. Sounds bad. Limitations, what do they say? Okay, let's go for it. So I'm like, how did I do for journals, by the way? Let's look at the code. Oh, and maybe the code has finished running. It has run in 6 minutes. let's have a look at the file it generated. Where did I add that? Where is the sorry, I can't remember where I've put the code. Okay. Okay, so this is the root, you know, the folder where I have the code, and this is where the file has been created. It's 11 megabytes, which is super small, given that in this file we have all the list of journals that exist, I mean, more or less. Let me open the file. As you see, each line is the same. Like if we take this one, it's the unique ID, which is the, by the way, very cleverly, it's just the URL of OpenAlex / unique ID, and then a pipe symbol, and then the name of the journal. And as you see, it's the encoding accepts non-ASCII characters, so it's pretty good. The title is in Arabic, Mandarin. I suppose this is classic Mandarin. Okay, well, fantastic. Look at that, I'm just impressed. Why do we have, oh yeah, sometimes we have very long title names. Okay, all good, but super satisfying. So, celebration. But now, if I wanted to have a look at how did I query, okay, you can just filter, select. So I'm going to do the same, but for authors. So I'm copy-pasting this function that I have written for journals. I'm copy-pasting it because I'm going to use the same for authors with modifications, of course. So the copy-pasting has taken place. So I go back to the, of course, it gives me an error, like this function already exists. Because, so all authors paged with cursor, yes, yes, same page size, everything is the same, so it's not total count. Oh, I should get the total count of authors first, right? So total count of journals, let me duplicate this one. And I'm gonna, I had a function to get the total count of journals. I'm gonna use it to have the total count of authors. It's exactly the same. So it's not authors, by the way, in the way they, how do they call authors in OpenAlex? Author, yeah, that's exactly that. Search authors, okay. Do I need a filter, or do I want all authors? This is where I could be modest and this is where I could reduce the number of authors I would retrieve. So what are the attributes of an author? So that I filter on things that make sense. Oh, something that makes sense is that the author should have published in the last 5 years if I want to count. Oh, and it should have at least published twice, because I want to see if an author has published in 2 journals. So I should have something like it should have an ORCID ID. Oh, the issue is, which ID do I need? Tricky, because OpenAlex is giving an ID to every author, but how do we know that OpenAlex has correctly disambiguated authors? So there should be I'm sure there is a discussion of that somewhere. Oh yes, exactly there. Page not found. Haha. So I should go on GitHub in any case. Our information about authors come from a variety of things. We use an algorithm to disambiguate authors. Well, they are not apologetic about their ID. So I should use the OpenAlex ID, I think. Okay, good. Okay, let's do that. OpenAlex ID, so let's not overthink that. Summary statistics. 2-year mean citedness, H-index. Okay, I don't care at the moment about that. Work count, exactly. So we need a work count of at least 2. Yeah, exactly. And hopefully they shouldn't, I mean, I don't have this information, but we want to have somebody who has published. Oh, but can we retrieve the publication? I hope so. Yes, I'm sure we can. Oh, that's going to be complicated. Oh, la, la. Oh, that's too bad we don't have an indication of did they publish in 2 different. Oh, counts by year. That's fantastic. Because we want somebody who has published at least twice in the last 5 years, right? Fantastic. So, okay, that's going to be useful. We want to have somebody. Let's see how many I mean, the count is going to be super useful. I don't know if I can do that. It's a list. Oh, that's complicated. No, I can't have direct access to the information. Let's not overthink that. Let's just do a count of how many authors have published twice in the last just twice, at least twice. So where is that? Sorry. Sorry, I'm a bit slow, but I lost the information. Works count. Okay, got it. So works count, that's the filter. Type. Oh, works count is there. Okay, so up. So above 1. Total count authors. Okay, that's so all the authors in OpenAlex who have published at least once, and I would have really loved to add another condition, which would have been, you know, like count, it's a list. Can I do a filter on a list? I'm gonna try that. Do they have something with filter? No. I mean, they don't provide documentation on that, and I suppose that's pretty heavy. So let's not do it. So get authors count, we're gonna launch that here in the main. I comment out the retrieval of all journals. I'm not gonna do that. And launch it. How many authors have published at least twice? Please, not too many. $39 million. Oh my God. Okay, 39 million. Achuma. The thing is, I'm becoming much more modest now. What if we were just counting authors that have published at least 5, you know? I mean, more than 5, not 5, 6 and more. $39 million, come on. $14 million. It's too much, too many. That's good. I mean, I actually don't care. I mean, I care, but I mean, that's enormous. Wow. It means we can be super picky. We can say 10. I'm going to say 10, and I mean, that's fantastic, actually. We're going to be able to create a map of science based on you know, on not senior authors, but as defined by senior authors. And we could compare that to the map of science as defined by, you know, authors with a lesser productivity. We do introduce a bias. You know, if the works count is above 10, for example, I am barely in this situation, and in some, yeah, and in some fields of science, actually, you don't publish that much that quickly, like in the humanities. So if I introduce a big work count, it's gonna be a bit. It's not gonna be. That's gonna be a bias. Like the map is not gonna be of the same quality in all areas of science. If you have any advice or, you know, or suggestion, it's a super exciting topic. I mean, I'm amazed. How can we filter out authors? Or we could take ORCID, just the ones that have an ORCID ID. Let's try that. Only the ones that have an ORCID ID. It should be less. It should filter out many authors. So how do I filter that? IDs. How do I filter on IDs? How do I filter authors? Oh, has ORCID. Fantastic. Has ORCID equals true. Bah, super. Thank you. Ooh. Okay, so I want all the authors that have an ORCID ID and who have published at least two, things. So let's go. Much better. 2 million. Just above 2 million. I'm good with that. 2 million. What? I'm going to do a last check on what I could filter out. I'm not sure we're going to find any strategy. But 2 million. Such an improvement as compared to where we started. Oh, I could have something like cited at least once. Let's try that. You know, we want to have a map of science that is based on sciences that were published, that were cited at least once. So that can be discussed and stuff. But honestly, it's kind of legitimate, I would say. So cited by count at least once, and maybe I'm going to jump to 2 actually, you know, but let's do that. Cited at least once. C'est parti. Less than 2 million, I'm sure. I mean, it's going to be significant. Error when retrieving initial count of journals. wait, no, it's not journals, it's authors. I just made a mistake here. Why is it not happy? Oh, maybe because I've put a comma here, a space, I mean. So let's try it again. Yeah, that was the space. Oh, look at that! 1,600,000, which is okay, because then, so we're gonna stop there today. I hope it's a good cliffhanger. Let me do the calculation of, so let's say we have 1,700,000 authors to retrieve. We're gonna retrieve them by batches of 200. So it's 8,000, a bit more than 8,000 calls to the API, and we do about 10 calls per minute. So it's 800 and not per minute, per second. So I'm gonna divide that. I'm a bit lazy, sorry. I'm dividing that per, so I do 600 calls per minute. So let's do 500 calls. So it should take 17 minutes to retrieve all these, like this close to 2 million authors. I've done that at the beginning of this session for journals, and we had the surprise to see that actually, you know, the theoretical duration is completely it's an underestimate. Actually, it took much more than that. So if I count 17 minutes, theoretically, I should expect an hour or two, or more, 3 hours maybe. So either I do that during the week, or we do that next week together. But as it's going to take hours, I would prefer to have it run during the week so that next week we actually move to the next step instead of waiting for the data to be fetched. Brilliant. Okay, thanks for being such a big crowd. Again, I've never seen such a big audience, so it's great. It's good for the energy. And let me move back to full screen. Yeah. So next week, what we're gonna do? Hopefully, I have all the authors as we did here by next week in a file. Nothing fancy, not a database, whatever. And what is going to be next is I retrieve for each author. That's a big number of calls. For each author, I retrieve the journals, the name of the journals where they published in the last 5 years. And once I'm there, I can leave OpenAlex alone, and I can then do computations with you. We're going to do computations to calculate the similarity between journals based on how many authors published in any 2 journals in common. Thanks, Veronica, for being here. We make progress, so that's great. And yeah, and see you next time. Thank you for staying. Bye-bye.